Law of sines. Let's first talk about the standard labeling that we will use for these oblique triangles. We will call our three angles alpha, beta, and gamma. And then we'll use lowercase letters a, b, and c for the sides. We'll always put side A opposite angle alpha, side B opposite beta, and side C opposite gamma. You might also see for the angles capital A, B, C instead of alpha, beta, gamma. Remember, this is an oblique triangle. That means there is no right angle, which means we have no SOHCAHTOA and we have no Pythagorean theorem. Those things are only true for right triangles. Well, what do we have? How are we going to be able to work with these oblique triangles? The first tool that we're going to learn about right now is called the law of sines. In words, it says that in any triangle, the sine of an angle is proportional to its opposite side. Here's what that means. If you form the ratio of the sine of an angle with its opposite side, notice that I've got sine alpha paired here with its opposite side A. If you form that ratio, you'll get the same answer no matter which angle side pair you happen to be using. Do you see that this is in fact three equations in one? There's the one that links angles alpha and beta, the one that links angles beta and gamma, and the one that links angles alpha and gamma. Three equations in one, the law of sines. Now, where did this come from? I mean, how do we know that this is a true statement? It's actually pretty easy to derive. If I take my triangle here and I drop a perpendicular from that top vertex down to the bottom side there, forming a right angle, I have actually now created myself two right triangles, the one on the left and the one on the right. Let me call this length h for the height of the triangle. Well, since I now have two right triangles, I can use SOHCAHTOA. Let me focus on the one on the left side first. In that right triangle, I could write the sine of angle alpha. Let's see, sine is opposite h over hypotenuse c. And then let me turn my attention to the right triangle on the right side. In that triangle, sine of gamma is equal to opposite h over hypotenuse a. A would be the hypotenuse in that triangle. Let me clear the fractions in both of these equations. Watch what happens when I do that. This one says c sine alpha equals h. And this one says a sine gamma equals h. Well, if they're both equal to h, then they're both equal to each other. And I can write down c times sine alpha equals a times sine gamma. Well, all I need to do is divide both sides by a times c, and if I do that, I will have the law of sines. On this side, the c's cancel. On this side, the a's cancel. This says sine alpha over a equals sine gamma over c. It's that third version of the law of sines. And you can derive the other two versions in a similar manner. We will be using the law of sines to help us solve triangles. That just means to find the missing angles and sides. Typically, we'll be given three pieces of the triangle at the start, and we'll categorize the problem based on the three pieces that we're given. For example, maybe we'd be given this angle, and this angle, and this side. Well, we'd call this an AAS problem, meaning two angles and not the side in between the two angles, but a side opposite one of the angles. Or maybe we'd know this side and this angle. Well, we'll call that SSA, two sides and an angle. Again, not SAS, which would mean the angle is between the two sides. SSA, the angle is opposite one of the sides. Each category of problem will have its own solving strategy. Thanks for watching.